And then I would just take that formula and write it down right on my page that I'm working on, right on my scratch paper. So it's a sub n equals a sub 1 times a common ratio raised to the n minus 1 power. A reminder, a lot of times we like to just kind of write this in parentheses. It's not a bad habit to get into. You can see they did it right here. Okay? There's my explicit formula, which means I need to take my number 12 and plug it in for the n's. So I have a sub 12 equals a sub 1, which is 0.5, times my common ratio, -2, and then I have n minus 1, which is 12 minus 1. Just helps to see it in your own handwriting sometimes. That way you know what all the pieces are. That is a plug and chug problem. All right, we had 0.5 times, and in parentheses, we had a -2. And we raise that to the n minus 1 power, which is 12 minus 1. It gives us negative 1,024 as the term. So a sub 12 equals negative 1,024. That kind of seemed a bit odd to me, so I started thinking on it a little bit. My first term is a positive, okay, positive half. When I multiply it, my second term would be a negative number, meaning my third term would be positive, and my fourth term would be negative, because this is an oscillating ratio. That means all my negative terms should be my even terms, making the 12th term make sense. Also, if I multiply by 2 slowly but surely, I am going to get some rather large numbers. Number 17, explicit arithmetic. That means we check the formula sheet. That's my a sub 1. That's my common difference. Find the 52nd term. That means that n is 52. Just like on the last problem, it was 12. And it's a plug and chug problem from there. -26 plus n, which is 52 minus 1, times our common difference of 100. I usually just type it out like that. Okay? Tells us that our 52nd term is 5,074. Now, could you have done this a different way? Yes. You could hop in the calculator and start with your first term, -26, and add 100 to it. That's my second term. Third, fourth, fifth, sixth. Gosh, I really don't want to hit that enter button 46 more times to get to my 52nd term. Not to mention, if I'm doing that, there's a high probability that I'm going to get it off by 1 term here or there when I'm trying to count. It'll be a quiet, nice testing environment tomorrow that still makes it kind of tough to count 52 enters of the trigger on your, not trigger, of the button on your calculator. Okay? 18, explicit geometric. Find the 8th term. Okay? So again, n is 8 here. N is 8. And we're off and running because this is explicit. That's the type of formula we really love to have if we're finding a future term. So we're going to look for a sub 8 equals -3 times 2 raised to the 8 minus 1 power, and it's plug and chug. -3 times 2 raised to the 8 minus 1 power, and we get -384. Number 19 is where all the students that are going too fast hit a roadblock. Given the recursive formula for the arithmetic sequence, find the 52nd term. And here's the roadblock everyone hits. They go, oh, okay, so I want a sub 52 equals a sub 52 again, minus 1 plus 200. And then they go try to slap this in their calculator, and I get them coming up all the time to me, Mr. Sorrell, how do I go down here? How do I go down here? You don't. It's a trick problem. It's giving you just enough information to make you try to do something that you can't do. What this would actually be is saying that to find the 52nd term, we need the 51st term. And I don't want to do this all the way back until my first term. So let's take a different approach. Let's think about the things we know. We know the first term. And because this is the recursive formula, okay, because it's the recursive formula here, we know that whatever number is tagged onto the end, not n minus 1 down the subscript, whatever number is tagged onto the end is the common difference. So I know my a sub 1 is -1, and my common difference is 200. With that information, guess what? We can use the explicit formula. A sub 52 would be my first term, -1, plus n, which is 52, minus 1, times my common difference, 200. Now it's a plug and chug problem. -1 plus 52 minus 1 times my common difference is 5,099. Oh wait, did I just type in 100? I did. Ooh, another mistake. 2 of them in one test. 200 is the common difference. I get 10,199. Number 20, recursive formula is given again. That's not a good way to find the 8th term. Can you do it? Sure. You had to find the 7th term backwards, the 6th term, 5th term, 4th term, and there we go. Now, this one is one that I think you can do without the explicit formula. If you're clever, you know that 2 is my first term, and every step of the way, I'm using my common ratio times 3. So this one is one you could do in the calculator. 2 times 3, it's my second term, third term, 4th, 5th, 6th, 7th, 8th. Again, just finding the 8th term is very doable by just hammering out the long way, okay, kind of using our calculator version of the recursive formula. And we find that a sub 8 equals 4,374. Now let's check that using the explicit formula. It's always good to check yourself on the test. Our explicit formula, okay? I should probably show you on the formula sheet, that way you get to see it. Let's play the checking game again, explicit formula. All we need is 2 pieces, a sub 1 and r. And on this in particular problem, they gave us what n was going to equal. So a sub 1 is 2 times r, which is 3, raised to the n minus 1 power, which is 8 minus 1. 2 times 3, parentheses that just in case, raised to the 8 minus 1, 4,374. Did it both ways, got the same answer both times.